Hi, today we are doing 10.1 Radical Expressions and Graphs. I would like everyone to read the notes and I am going to work on the examples with you. So please read through the notes and once again, I will work through the examples. First of all, we're going to talk about square roots that I feel everyone should memorize. So these are perfect square roots. So I want to go over what this perfect square roots are. Let me go back to this part here. So what I'm going to do is I'm going to write down perfect square roots that you're going to have to memorize. When I say you're going to have to memorize, you need to make sure that you do not forget them. For the ACT exam, you need to know what the perfect square roots are. So the square root of 1 equals 1. Square root of 4 equals 2. The square root of 9 equals 3. The square root of 16 equals 4. The square root of 25 equals 5. The square root of 36 equals 6. The square root of 49 equals 7. The square root of 64 is equal to 8. The square root of 81 is equal to 9. The square root of 100 is equal to 10. The square root of 121 is equal to 11. The square root of 144 is equal to 12. The square root of 169 is equal to 13. The square root of 196 is equal to 14. And the square root of 225 is equal to 15. Those are all perfect square roots that you must memorize. Then we also have cube roots. Okay? So cube roots, these are things that you also have to memorize. And these are all things that the ACT exam expects you to remember. So the cube root of 1 is equal to 1. The cube root of 8 is equal to 2. The cube root of 27 is equal to 3. The cube root of 64 is equal to 4. The cube root of 125 is equal to 5. The cube root of 216 is equal to 6. So those are all perfect cube roots that you have to memorize. Now, there's also fourth roots that they expect you guys to remember. Now, the fourth root of 1 is equal to 1. The fourth root of 16 is equal to 2. The fourth root of 81 is equal to 3. That's pretty much all they expect you guys to remember of the fourth roots. Then we have a fifth root, and then you're pretty much done after this. So the fifth root that you have to remember is the fifth root of 1 is equal to 1. The fifth root of 32 is equal to 2. So these are all radicals that you have to memorize. You will see them on the ACT exam, and there's something that they just expect you guys to know. Alrighty, so just keep those, refer back to them if needed. So what we're going to do right now is we're going to jump over to where it says finding square roots. On example 1, find all square roots of 64. So there's a couple ways to do this problem. If I ask you what the square root of 64 is, it is going to be 8 because that is a perfect square root. There is another way to write this as we all know that 8 times 8 is 64. So we know that 8 squared is also 8. And the way to see this is normally a 2 right here where it says squared, but you don't ever put a 2. Now, if it was a cube root, you would put a 3 right there. That's known as the index. So 8 squared, the square root of 8 squared is equal to 8. the square root of 64 is equal to 8. So here's another way that you could do this as well. We have 64. This is breaking it down by primes. So I know 4. Here we go. Well, I'm just start with 8 times 8. And then 2 and 4. And then 2 and 2. Now, because we have a square root, I need these all to be squares. So I have a total of 1, 2, 3, 4, 5. I have 2 to the 5th power. Whoops, I forgot this one up here. Woo! Okay, I actually have 2 to the 6th power. 2 to the 6th power is 64. So if I have 2 to the 6th power, I can break this up as 2 squared times 2 squared times 2 squared. Whoops, don't know what I was thinking. Okay, so I just broke this up as primes. So 2 squared times 2 squared times 2 squared is really 2 to the 6th power. Well, remember, if you're square rooting something that is squared, whatever's being squared comes out, okay? So in reality, I have the square root of 2 squared is 2. The square root of 2 squared is 2. The square root of 2 squared is 2. 2 times 2 is 4. 4 times 2 is 8. So that is just another way to break this down if you wanted to. I personally use perfect square roots. I just think it's easier. You've got to know that the square root of 64 is 8, and then you're all good to go. But if you were ever in doubt, you could break it down into primes if you needed to. Okay? All right, so that's just a little bit of information. I hope you guys go back to this and you look at this and you know that you need to know what perfect square roots are. You need to know what perfect cube roots are, perfect fourth roots are, and perfect fifth roots. These are things that you will see on the ACT exam. All right. So now what we're going to do is we're going to learn about finding square roots. First of all, the radical symbol is the square root symbol. The radicand is what's under the radical. The whole thing is known as a radical. Now, this little portion right here, this little part right here, this is known as the index. If you do not see a number there, that is known as a square root. If you do see a number there, it's whatever that index happens to be. And it could be a cube root, a fourth root, 100th root, whatever it happens to be. All right, so now let's do a couple of problems. Here's something that you guys please read. Basically, whatever's under the radicals, you can multiply together. Whatever's outside the radicals are multiplied together. So first of all, on this problem here, all we're going to do is we are going to simplify the square root of 169. If you notice the square root of 169, it is a perfect square root. So the answer to this one would be 13. It also means the square root of 13 squared, which is 13. 13 times 13 is 169. So that's where I got 13. Now on this one, it's a little different. The negative is on the outside of the radical. And then we have the square root of 225. Now, as long as you remember that the negative is on the outside of the radical, the square root of 225 is 15. So your answer is negative 15. Okay, the negative is not under the radical. If it was, it would be considered an imaginary number, which we will be learning. Now, this one here can also be written as the square root of 25 over the square root of 64. If you want to break it up as what's in the numerator and what's in the denominator, you can. The square root of 25 over 64. If you want to actually see the square root of 25 over the square root of 64, you can. Now, the square root of 25 is a perfect square root, and that is 5. The square root of 64 is 8. So your answer is 5/8. Now the next one, squaring radical expressions. Again, find the square of each identical expression. So what they want you to do is just to find the square of each radical expression. Now, if you're just finding the square, I take it that they just want you to square it. So I'm going to square this, and that's going to give me 17. Because the square root of 17 times the square root of 17 gives you the square root of 17 squared. And when you square root something that is squared, whatever's being squared comes out. So you get 17. That's okay. So on this problem, you could not square root 17 because 17 is a prime number. You can't simplify it any further. But if I were to square each of the radicals, I'm actually squaring that whole radical, I would get 17. Same thing here. If I were to square this whole radical, I would get a negative square root of 31 times a negative square root of 31. And that would give you a negative times a negative is a positive. And I would get the square root of 31 squared. By the way, the square root of 31, you can't simplify it. It also is prime. Now, the square root of 31 squared is just 31. That's it. So I took it that we're squaring these problems, okay? Now, letter C, you're squaring the radical. Now, because you're squaring the radical, you're taking the square root of 2x squared plus 3, and you're multiplying it by the square root. Let me just put little parentheses around here. All that means is you're just writing it down twice. Now you end up with whatever's under the radical. It means you have two of them. So that is squared. So that's going to be 2x squared plus 3 to the second power. Now remember, whenever you take the square root of something that is being squared, whatever's being squared comes out. So that what's inside the parentheses is going to give you 2x squared plus 3. And there you get. All right, so those are those two. I'm going to do one more thing. We're going to talk about rational, irrational, or not a real number. You can square root 25, and when you square root 25, you get 5. You can square root 144. When you square root 144, you get 12. Same thing with 4/9. You could square root 4/9. The square root of 4 is 2. The square root of 9 is 3. Just remember that real numbers can be written as fractions. They have a decimal that terminates or repeats. Like 2/3 is 0.6666666. An irrational number is like pi, meaning it never terminates and it never repeats. It's 3.14 and then the numbers just keep on going and they don't ever repeat, okay? So sometimes you might get like the square root of 2. That is irrational. You can plug it into the calculator, but it eventually stops in the calculator. But in reality, it just keeps on going. Alrighty? So that's what an irrational number is. And it's also in the vocabulary if you want to take a peek at that. So on this one, tell whether each square root is rational, irrational, or not a real number. When it's not a real number, what it means is you have a negative under the radical. So on this one here, the square root of 27, I know that the square root of 9 times the square root of 3. Now, the square root of 9 times the square root of 3 is the square root of 27. Whatever's under the radicals, you can multiply them together. So what happens is the square root of 9 is 3, but you cannot square root 3 because it's just the square root of 3. Now, the square root of 3 itself is not it's irrational, meaning when I plug it into a calculator, it just keeps on going. I multiply it by 3 and it just keeps on going. So that would give you an irrational number. Now the square root of 36, we all know, is 6. The number 6 terminates. It's just 6. That is a rational number. Now the square root of 16, negative 16, that means there's a negative under the radical. So I can rewrite this as the square root of 16 times the square root of negative 1. Now you end up with the square root of 16 is 4 and the square root of negative 1 is I. You guys, you have to remember that imaginary numbers, the square root of negative 1 is I. I squared, just in case you forgot, is negative 1. These are imaginary numbers. So this one here would be imaginary, which is not a real number. So this would be imaginary. Imaginary number. This would be a rational number. And this would be an irrational number because it does not terminate or repeat. Alrighty.